Hi everybody, Miss Cechek here again with you to talk about the 33.2 notes. And this time we're going to shift our focus from prisms and pyramids to cylinders and cones. So as your warm-up today, take a moment on your own and try and name the three-dimensional shape that could be represented by both of these real-life examples. Well, maybe you took a cue from the top of the page with the notes, but notice this can here is a great real life example of a cylinder, and the party hat we see is a great example of a cone. So these two things here, some basics about cylinders and cones for vocabulary. Cylinders have two circular bases, okay? They have two circular bases, one on top, one on bottom. Now, we talk about the height of our cylinders like we did when we talked about height with parallelograms or trapezoids, that you want to look where it's perpendicular. Always looking for the perpendicular height. So again, got to see that right angle there. Because if it's a right cylinder, as you see here, straight up and down, that is the height. But if we end up with a slanted cylinder, which you will occasionally see, then you got to be careful because the height is going to be where it's perpendicular. And again, this is a great example of a right cylinder, the picture that's given, where the height and the radius intersects to form a right angle. The circles are kind of on top of each other. A little example of an oblique, as we call it, cylinder would be something like this, where it's a cylinder, but again, notice here the height, we're going, top to bottom, is actually here would be what we would consider the height. And again, this would be an example of a non-right cylinder, what we would call an oblique cylinder. Okay. Now, as far as cones go, they are very similar. Hence why we're talking about them with the cylinder. That their base is a circle, but they only have one. Okay. And again, the height is going to be where it is going to be from the vertex to the base. All right, they're going to intersect to form a right angle. It's not going to be slanted. All right, so we got to have, again, that right angle to be considered the actual height on this one. Okay, and again, they're going to intersect to form a right angle, and you see the radius and everything there. Vertex, very similar to the pyramid, has a peak point there where they intersect. Okay. Now, down below here, we have a carpenter purchasing a hunk of tree wood, and he wants to shape that into a circle, an oval, and a rectangle if he slices this. So how could he cut the tree to make that shape? So we want to go back to that vocab word we talked about in the last lesson, and that's cross-section, right? And that shape that we can create if we slice this a certain way, how can we slice this to see this? So if we want to slice it so that we see a circular cross section, all right, what we're going to notice is we're going to want to slice it right inside of here like so. Rectangularly, we're going to take it here and look there for our rectangular cross section. And also with our oval cross section, that's going to look something like this. Now, to kind of confirm this, if we look on this, and you'll see this as you flip to the next side as well, we talk about a cylinder here. All right, notice we were using this yesterday with prisms and pyramids. We can kind of confirm this, that if we start by making that horizontal cross section, no matter how many, no matter what, we see that we have that circular. And if we move this slice up and down, no matter the size of our radius, big, small, we're creating that circle. Now, if we turn this vertically, that's again where we're going to, no matter the size of our shape or where we move this, that's where we're going to, with that perpendicular cross section, see the rectangle. And then last but not least, if we move this slice so that it is horizontal, all right, notice this is where we can see that oval shape to it. And again, if we move it around a little bit, we could start seeing that oval shape to our cross section. Okay. And that's again what they kind of want us to play around with here on the next page. Is going back to that website that we talked about from yesterday, and that's the website that I was on there, this shoulder.org. we have a really good visual then of our cross section. So if we talk about these when it's parallel to the face, and if you want to follow along and you're back on this website, for a cone, right, we would have a horizontal cross section here, and no matter where we move it to slice, notice we are getting the shape of a circle on this right hand side all around here. Notice each time it is a circle. Okay, now for our cylinder, when we do that, again, no matter what, notice up and down, this is a circle. Okay, and notice if we change the size of our radius here, no matter where we slice it though, we are getting a congruent circle. This circle is not changing size no matter how we move it. It's a congruent circle. Unlike with that cone when we were changing it, it was still a circle, but they were just similar in shape. They weren't congruent depending on where you sliced it. Okay, so that's some important things to note right there. So for both of these, we're going to get a circle as the parallel cross section. Okay, and again, if you want to kind of draw yourself a visual, that circle's coming here. We have the circle here inside of this. Now, if we talk about perpendicular cross sections, okay, notice here when we talk about perpendicular, if we change this around a little bit, and notice this picture here, they want us through the vertex for this particular cone because you're going to get a different shape depending on where you're at for that. We're going to move this slice so that it is through the vertex. Notice very similar to what we talked about yesterday with the pyramid. When you are through the vertex, no matter the size of this, it's creating a triangle on this particular one. So we're going to see a triangle when it's through the vertex. Okay. Now, if we're perpendicular with our cylinder, right, something you're going to notice is that no matter where we move it perpendicular, the shape is always a rectangle. Okay, and again, no matter if we change the size around and move this, no matter where we're slicing this perpendicular, we're getting a rectangular shape on this one. So we would have a rectangle as the shape on this one. And again, you may want to draw in some pictures to represent on these. In this case, we would see this like so. Again, that rectangular shape. Now, another way I like to think about the cylinder problems and the shape that it's making is if we go back to looking here at a soup can, for instance. So it's a great example of a cylinder. And imagine we sliced on the label and we unwrapped that soup can label. Notice it would lay out flat like a rectangle. So again, going back to the notes, this is something that I like to think about when, for example, 3, when we want that perpendicular cross section, when you unwrap that soup can label, you're going to see a rectangle. So that's where we can kind of remember, oh, when we want the perpendicular cross section, it's a rectangle. Okay, now example 4 is asking us for a right cylinder sliced parallel by 3 different planes. So imagine we're slicing this boom, 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 3 different spots. How will we describe not only the shape, but also the size of those 3 cross sections that we're forming? Well, again, to kind of test out our hypothesis, let's go back to this example here. And if we're slicing parallel 3 spots on this particular cylinder, we'll make it this right here. Notice if I slice it here, if I slice it here, or if I slice it way up here, this shape here of our circle has not changed one bit. So what we're going to see here is no matter where we slice this, we're going to get a circle each time. And not only we're going to all 3 be a circle, but they are going to be congruent circles. Okay, so congruent circles. Reminder, congruent, you might think of it, this sign here for congruent. Okay, now if we do that same experiment, all right, with a cone, so we're going to slice our cone in 3 different spots. So notice the example they're giving us here. We're going to slice it boom, boom, boom. Do we think we're going to get the same results? Okay, take a moment. Think to yourself, well, what do you think? Are we going to get those same results? Well, if we slice here, notice the circle we have on here, versus if we slice here versus the shape we have slash size versus if we slice way down here. Okay, notice the shape and size we have on this one. Okay, so the difference here is, all right, these are also all circles, but depending on where we slice it, they're just going to be similar to each other. Okay, they're all going to be circles, but they're just similar. So in this particular example, again, when we slice here versus here versus here, these are going to be similar circles. And a reminder, the sign for similar is just one little squiggly like that, one little tilde is the Greek letter name for that one. Okay. Now, in closure, what formula would we use to find the area of a cross section of a cylinder or cone when it is sliced parallel? Well, first, take a moment to think about, well, what shape am I creating if I am going to slice it parallel to the base for either of those? And then you need to think about, well, what is the area formula for that shape? So hopefully you answered that you would be looking for the area of a circle, and the area formula for that is pi r squared. And again, why is that? Well, the cross section for a parallel cut is a circle. So that's why we had to use the area of a circle formula. Okay. All right, guys. Thanks for listening, and good luck with the practice.